Every day we're on the edge of our seats, waiting for news about what's going on in outer space. Today's video brings you just that, new mysterious findings from the JWST. One of the scientific truths that the new James Webb Space Telescope is revealing is the vast immensity of the cosmos. The space-based telescope has recently discovered a massive object hidden in the universe. What could it be? Is it possible for a new discovery in this vast universe? Stay tuned to the end to discover more about this mysterious finding. What is 100 times the size of the Milky Way galaxy? The power of the James Webb Space Telescope is a phenomenal invention. Why do you ask? Since its mirror is 6 times bigger than the Hubble telescope, it can gather far more light and see further into the past. It is also capable of studying infrared light to a far larger extent. There is little question that its introduction will lead to additional advances in space science, suggesting that the telescope's relatively high development cost of $10 billion and the complexity of its design are well justified. Both scientists and the general public continue to be amazed by the magnitude of objects in space. One of the largest things ever discovered, the Alcyonius galaxy is evidence that nature is compelled to fill the vast, broad space that exists and has potential for life. Its unintended discovery, which is also typical of many other breakthroughs or findings that have changed the course of human history, only adds to its allure. Alcyonius is a radio galaxy with a supermassive black hole at its center that produces and releases energy in the form of two-wave radios as matter falls into the black hole. Jets from the opposite side of the galaxy's center are unusual phenomena that originate in low-density environments and have a total anticipated linear length of at least 2.3 million light-years. They're also known as active galactic nuclei radio galaxies. Researchers took the name Alcyonius from Greek mythology, and they chose it because it was a giant who fought Hercules and other gods for control of the world. Alcyonius was the son of Uranus, the original sky deity. Scientists observed the newly created galaxy with 2 plasma plumes, which is rare because no other galaxy has ever produced such massive objects. However, the sphere of the effect of certain galaxies is known to extend far beyond their immediate environs. So, how big is the Alcyonius galaxy? Scientists can only capture astronomical photographs from a single angle. They can only make an educated guess about how long a universe is, since it is that of the Earth. Even while scientists usually measure an overall length lower than expected, in the case of Alcyonius, the low estimate is nevertheless incredibly amazing. It would take 100 Milky Way galaxies to align the galaxy's more than 16 million light-years. Alcyonius was found using the second data from the Low-File 2-meter Sky Survey, or LOT-DR2. Reprocessed by removing angular compact objects and imaging at 60 and 90 resolutions, the picture enables them to explore a new sensitivity domain for radio galaxy lobes and providing exciting evidence for the search for undiscovered radio galaxies of large angular length. With Alcyonius being near Earth in terms of cosmic distances, only 10 of more than 1,000 radio galaxies identified by scientists are longer than 10 million light-years. Astronomers think the huge galaxy occupies an area in Earth's sky equivalent to the Moon's. It is slightly more than 3 billion light-years away, almost in our galaxy's backyard. Scientists were enthusiastic by the Alcyonius finding because its plumes give information about some of the most challenging to characterize strands of the cosmic web. The present adult cosmos, which resembles a network of threads and nodes, known as filaments and clusters, is referred to as the cosmic web in this context. Observing galaxy filaments and clusters is not difficult, although it has only been done a few times. Identifying the medium between galaxies is challenging. Alcyonius inhabits a filament, and since its plumes face a headwind as they move across the medium, scientists anticipate that it will change this. Researchers have hypothesized that filament characteristics may harm the conditions and pressures of the radio galaxy's plumes for many years. However, scientists had never discovered a case of such a link before the discovery of Alcyonius. They now show that because Alcyonius's plumes are so big and uncommon, the surrounding medium may easily mold them. This event also happens when a Milky Way is present. But what makes it notable is how the direction and form of the plumes are subtly altered. But how did Alcyonius become so enormous? There are other theories. The scientists who discovered Alcyonius thought a massive black hole created it. They found that Alcyonius did not stand out in the 3 properties mentioned above, even though many stars with a lot of stardust had exceptionally powerful jet streams. Alcyonius's origins is, in actuality, still unknown at this point. As any high school geography student will tell you, many people know planets have moons. For instance, the Earth has one, but other planets like Jupiter and Neptune have several moons. Although there are only around 150 asteroids with moon companions among the roughly 1.1 million asteroids detected, scientists have found an incredibly uncommon asteroid with 3 moons. It is important to note that Electra was first identified as an asteroid in the 19th century. Still, it wasn't until recently that scientists confirmed its role as the supreme commander of the Army of 3 Moons. In 1873, they found a 160-mile-long asteroid in the belt of asteroids between Mars and Jupiter. Electra's first moon was discovered decades later in 2003, and scientists discovered its second moon in 2014. Additionally, 130 Electra showed scientists how to detect other faint, difficult-to-find moons, such as those attached to asteroids. Any object even smaller placed to an asteroid would be duller and fuzzier because its parent asteroid will considerably outshine it because the asteroids are relatively small and only weakly illuminated at best. As a result, moons that are smaller or closer to their planet will be challenging to spot. Exoplanets orbit their anchor stars for identical reasons. Although they are highly elusive, the first moon is 6 kilometers long and orbits Electra at an average distance of around 1,300 kilometers. The second moon is considerably smaller, measuring just 2 kilometers broad, and orbiting the asteroid at a distance of approximately 500 kilometers. Anthony Perdue and his colleagues from Thailand's National Astronomical Research Institute founded the third moon orbiting Electra. It is difficult to notice the newest moon since it is the smallest group and is around 15,000 times fainter than the asteroid. Its length is barely 1.6 kilometers. The study team painstakingly reduced noise from the raw data from the spherical instrument mounted to the European Southern Observatory's extremely big telescope using a freshly constructed data reduction pipeline. With a 10-meter telescope, the sphere can extract photos of extremely faint things and take incredibly detailed photographs of objects in space. Intriguingly, the third moon was found in earlier photos utilizing contemporary processing methods. They use data processing techniques to forecast and remove the halo, or broad light, from asteroids. Electra's third moon occurred after scientists had analyzed the data. Consequently, the moon was there throughout the processing, but was not apparent to the techniques used in 2005. Electra and her moons are still a mystery to scientists in many ways. For instance, they don't know how 4 objects got to be connected. Scientists haven't yet determined how frequently the procedure took place in the solar system, but it is one theory for how 2 moons of the asteroid Cleopatra formed. They concluded that the twin moons most likely formed from a material that the parent body had ejected. All 3 moons may have formed similarly to how the Earth's moon did, which suggests that they were most likely created by an asteroid striking Electra. Increasing the precision of mass estimations is why researchers searched for asteroids that circle the moon. The size and composition of an asteroid can be used to estimate its mass in the absence of a moon, albeit the method may provide unreliable findings. The density of an asteroid can be estimated from its mass and size using a set of Kepler equations, which provides a wealth of information about its composition. This information can determine whether an asteroid consists of metals or is simply a mass of low-density rocks bound together by gravity. As a result, learning about asteroids' moons is the only way to get much more information about it. The discovery of Electra's third moon also acts as a test run for a technique that may fundamentally alter how we discover celestial objects. It's crucial to remember that the moon was founded by adopting a strategic look at old data. As a result, numerous moons may still be waiting to be identified in the old data. All it takes is a new perspective. Do tell us your views in the comments section. If you've reached this far, like this video, subscribe to our channel, and press the notification bell so you don't miss out on any future updates. See you in another video. Until then, take care. Till then,